When visiting a port, have you ever seen a small boat pulling a large ship that is docked in the harbour? Or perhaps you've witnessed a small boat pushing a large ship that is experiencing engine problems. The small boats responsible for pushing or pulling these large ships are called tugboats. Tugboats are essential in various industries, especially maritime and oil industries. In the maritime world, tugboats play a crucial role in safely guiding large vessels through narrow passages, busy routes, and shallow waters. This towing can be done through two methods: direct contact between the tugboat and the other ship, or by using towing lines. It's important to note that large vessels like container ships, tankers, or ferries cannot make sharp turns at low speeds. This is because the water passing through their rudders is not sufficient to facilitate quick and sharp turns. Therefore, tugboats are needed to push and pull these ships into their designated positions, such as berths in the harbour. Tugboats can be divided into two types: escort tugboats and support tugboats. Escort tugboats are used to assist in navigating, escorting, and stopping large vessels in coastal and hazardous waters. Meanwhile, support tugboats have less demanding tasks and are often used for offshore operations like oil platforms or as firefighting vessels. Generally, tugboats come in three designs: conventional, tractor, and azimuth stern drive, ASD. Each design has its advantages and disadvantages. Conventional tugboats are relatively easy to build, have lower operational costs, and are easier to maintain. However, they are less powerful and have a higher risk of capsizing compared to tractor and ASD tugboats. The next design is the tractor tugboat, which offers advantages such as increased stability and more advanced maneuverability compared to conventional tugboats. However, it has higher maintenance costs and lower towing capability than ASD tugboats. The third design, ASD tugboats, excel in operating in deep sea waters and have higher towing capabilities than conventional and tractor designs. However, ASD tugboats have complex control systems and are more prone to rolling or capsizing when using a towing line at the rear of the vessel. Considering the toughness of tugboats in performing their tasks, what gives them the strength to pull or push large vessels? The secret to the tugboat's strength lies in its bollard pull, which is the thrust developed by the ship's propulsion system at zero speed. Simply put, bollard pull is a measurement used to determine a ship's towing strength. There are two types of bollard pull. Static bollard pull, measured after testing, begins with calm waters, allowing full power, and continuous bollard pull, measured over a 10-minute period. The unit of force for tugboat bollard pull, as well as other ships, is typically in kilonewtons. Medium-sized tugboats generally have a bollard pull of around 500 to 600 kilonewtons. To calculate the bollard pull of a tugboat, it is moored to a dock using a bollard and then pushes itself forward with maximum thrust. The tension measured on the towing line indicates the total thrust achieved. For this calculation to be accurate, several criteria need to be met before the bollard pull test is conducted, including undisturbed water, sufficient clearance around the vessel, testing in deep waters away from river mouths, and unobstructed water flow. It's important to note that bollard pull conditions are never perfect. For example, the test phase may occur when the bollard and bits are not perfectly horizontal to each other, or when the water is not completely calm. Water salinity and the vessel's propellers can also cause slight tilting, affecting the accuracy of bollard pull calculations. Therefore, bollard pull test results may have some margin of error, In fact, Bollard pull calculations can also be done through computational simulations, but such facilities are limited and more expensive. Bollard pull for tugboats can be increased by designing more powerful engines, increasing the number of engines, and designing a sleeker vessel to minimize resistance. Many tugboat manufacturers strive to enhance the bollard pull of their vessels to attract buyers and increase sales. To operate, each tugboat is required to have a bollard pull certificate from a classification society such as the Indian Register of Shipping, IRS, or the American Bureau of Shipping, ABS. Once the bollard pull has been measured and the tugboat has obtained a specific bollard pull certificate, it is ready for operation. Generally, there are 3 methods for operating a tugboat: direct towing, indirect towing, and pushing. Direct towing is the simplest method, where a towing line is attached to a powered winch and then connected to the vessel being towed. After the line is secured, the tugboat will tow the vessel through the water at an average speed of 4 to 5 knots. Indirect towing is different from direct towing, as the towing line is attached to the stern of the vessel being towed, effectively pulling the tugboat. In this method, the tugboat uses its thrust to maintain a sideways position relative to the direction of movement, allowing for higher pulling force than its own bollard pull. Using indirect towing, a tugboat can sail at speeds of up to 6 knots or more. The third method is pushing, where the tugboat pushes the vessel to its designated position. Tugboats designed for pushing are typically equipped with strong hulls and additional devices attached to the vessel being pushed. Apart from towing, pushing, or relocating vessels, tugboats are also designed for various other purposes, especially search and rescue operations. One of these roles is ice-breaking. Ice-breaking tugboats are designed with sturdy hulls to withstand heavy ice damage and metal reinforcement. They are also equipped with twin-engine paddle wheels or cork nozzles that can increase thrust by up to 90%. In addition to ice-breaking, tugboats can serve as firefighting vessels in the event of a sea fire incident. This policy is in accordance with the Safety of Life at Sea, SOLAS, regulations. There are specialized firefighting tugboats operated by qualified firefighting crews. These firefighting tugboats are strategically placed to ensure rapid response to sea fires. They are equipped with high-pressure pumps, hose lines, and special barriers. Despite their small size, tugboats are incredibly strong vessels, especially anchor-handling tugboats. These tugboats are equipped with 3 bollard pull engines capable of lifting, retrieving, and relocating anchors weighing several tons. They are typically used for handling anchors at offshore oil platforms, towing them to the required location, and securing them. These tugboats are also frequently used for supply runs, providing towing assistance and relocating hazardous materials from specific areas. They also serve as transportation for workers from the port to offshore oil platforms and vice versa. Among high-powered tugboats, there are medium-strength tugboats, and even the weakest or smallest ones. These tugboats are typically used for towing or pushing smaller vessels, or supporting larger tugboats. Despite their smaller size, these tugboats are equipped with various features like typical tugboats, including firefighting equipment and the ability to assist in oil spills at sea or other emergency situations. Another function of tugboats is patrolling in a region commonly used by emergency services such as police, coast guards, and disaster relief operators. Specialized patrol tugboats are designed to reach speeds of up to 40 knots and usually operate around ports. These small vessels are often used for various types of marine biology surveys and research, seismic activities, hydrography, and oceanography. However, there are also specialized research and survey tugboats equipped with specific instruments such as drop keels and advanced radar mapping capabilities. Although most tugboats are highly powered, some tugboats have been recognized as the largest and most powerful in the world. Two of these are the Island Victory and 𝗖𝗂𝗲𝗃𝗀𝗃𝗀𝗃. Island Victory is the world's largest tugboat, measuring 123 meters in length and 25 meters in width. Designed by Kongsberg Maritime and operated by Island Offshore, this vessel has a dead weight of 5,686 tons, a deck space of 1,200 square meters, and a maximum draft of 9.4 meters. In addition to its general towing duties, Island Victory often performs oil recovery operations off the coast of Norway. To meet these operational requirements, it is equipped with storage tanks capable of holding up to 2,500 cubic meters of oil. 𝗖𝗂𝗲𝗃𝗀𝗃𝗀𝗃, on the other hand, is another large and powerful tugboat operated by K Line Offshore. It measures 95.2 meters in length, 24 meters in width, and has a deadweight capacity of 4,800 tons, with a deck area of approximately 750 square meters. Its main deck can carry cargo up to 3,200 tons, and its maximum draft reaches 7.8 meters. In addition to towing and pushing large vessels, 𝗖𝗂𝗲𝗃𝗀𝗃𝗀𝗃 can perform dredging, drilling, and underwater operations. The vessel features 45 cabins and can accommodate up to 70 people. These tugboats, despite their size and strength, showcase the remarkable versatility and significance of these vessels in various maritime operations and industries.